Good morning. Hola. It's Mr. McKenzie once again, starting our last lesson for chapter 5. After this chapter, we'll have an assignment. I'll give it to you guys on Wednesday. All right, so the lesson today is statistical bias. Okay, I mentioned bias not too long ago when in other lessons, so now we get to actually touch on it. Okay, so this is bias happens within when we're sampling. So remember, we have those bunch of different types of sampling. So some of them are simple, systematic, stratified, convenience, voluntary, cluster, multi-stage, and I believe I'm missing one of them. Okay, so we're looking at that. So within our sampling, we could have different biases. And biases, what they do is they affect the accuracy of your results. Okay, so sometimes it is external influences, but sometimes it's just the method at which you use. Okay, so statistical biases, external influences that may affect the accuracy of the stats, or its results in error that cannot be corrected by repeating the experiment many times. Okay, so number one is sampling bias. Okay, so it occurs when the sample does not reflect the population being studied. Okay, it's caused by the method of sampling. So an example of this would be non-random sampling and too small of a sample. So for instance, so if I went to, let's say, the basketball team and I said, what is your favorite sport? Then most likely they will all ask or answer basketball. And then I use that as my results. So that would be a problem because that wasn't random. Okay, I just choose one team. So my sampling has a bias. So in this case, it's who you're asking, and how many people. So who you're asking, how many. We say it's too small a sample. So if you only ask like 10 people their opinion, that would be considered a small sample. So for our purposes, we want to have a sample that is larger than, say, 50. Okay, I think in university they said something about a couple hundred you would need as a sample, but for our purposes, we'll just say we need more than 50 people, so greater than 50 people. So if you have only 10 people or 5 or 20, that's not a good sample size. Okay, non-response is when specific groups are underrepresented. Okay, it also occurs when only 80% of people respond. Okay, so we want to have more than 80% of people to respond. Okay, this often happens in mail-in surveys, so ones that you may send into the mail or you may send through email. 1 second. One second, guys. Just trying to log into my computer for something. Okay, so this is not enough people responding. Okay, so let's if it's under 80%, or certain people don't respond. Okay, and I'll explain that one when we get to some examples. Okay, measurement bias. Okay, bias occurs in measurement techniques. So often these are with regards to certain tools that you're using. Okay, or improper measurements caused by the person conducting this study. Okay, so usually this involves numbers and calculation tools. Okay, then our last one is response bias. Bias that occurs when survey participants falsely give misleading answers or purposely give false or misleading answers. Perhaps they don't want to be embarrassed. Okay, and they want to influence the survey results. Okay, this is often leading questions cause this. So leading questions. So remember the one we did with the cell phone in a couple sections ago was like, it said, which do you want to be alone in your classroom, or would you want to be able to use your phone so that you, what's it called? I forget what the exact one it was, but it was something that was leads you to say, yes, I want to use my cell phone. Oh, sorry, it said no communication at all. So that was a leading question. So you want to, it will favor one answer. Okay, so identify the bias in each situation and explain why. Okay, so the first one, a class of grade 9 boys was asked by their physical education teacher to put up their hands if they have had a date with a girl. Okay, so this would be a response bias. Okay, so maybe grade 9 boys, maybe very little or none have had a date before, but they want to maybe answer yes so that they would look cool. Okay, so they want to look cool, or maybe they want to fit the trend or whatever, or impress people. So chances are they might say yes. Okay, that would be a response bias because it's kind of a leading question, or kids don't want to be embarrassed. Okay, next ones. Okay, a survey question asks, do you think the Liberty government should be reelected to continue its good work on the environment? Okay, so this, again, is a response bias. Okay, because this is a leading question. Okay, so if you said this, you want the government to be re-elected to continue its good work on the environment. Well, you shouldn't have to add this part of the question to continue its good work. It should be, do you think the Liberty government should be re-elected? That's it. There shouldn't be anything after it to influence you and answer, okay? I will let you know that for some reason in this textbook, when leading questions, they put the answer in the back of the book as a measurement bias. It is not the best measurement bias. It is a response bias. Okay, for some reason, I looked it up online. My old textbooks, they all say response, but for some reason in this textbook, it says measurement. So if there's a leading question, please answer response bias. Do not put measurement as the textbook does sometimes. All right, next one. Oh, my letters are all off here. That should be C. This one is a repeat. Okay, to determine how people feel about a new project, 20 people were interviewed through a random selection of telephone numbers. Okay, so the random part is fine, but the issue here, there was only 20 people. Okay, so what bias is that? Well, we go back here. We want at least 50. Okay, so this would be a sampling bias. Okay, sampling bias. Too few were asked. Okay, so we want, so this one in this case was only 20. We want to have 50 or above. Okay, next one. The mayor wants to put some money into city's athletics, so she goes to the community center and asks people if that would be a good idea. Okay, so if you go to the community center, chances are they're going to say, yes, put more money into the city athletics. So, but what you aren't asking is other people. So this becomes a sampling bias because it's who you're asking. Okay, so we're only asking people at the community center, but we should be asking people everywhere. Okay, so this is a sampling bias. Sampling bias, it's based on who you ask. Okay, because we went to the community center. Okay, D, a neighborhood survey about children's playground equipment in a local park was sent to randomly selected households. That's good. Approximately 30% of people responded, and particular people in condominiums tended not to respond. Okay, so we have here, this is the percentage. So we go back to our previous question. So if our response rate is below 80%, okay, so that is a non-response. 30% return rate. Also, a way to tell this, over here, we said certain people are underrepresented in this. Okay, so in this question here, it said people in condominiums tend not to respond. Okay, so they would be represented as well. So first we have the 30%, and there were people that chose not to respond. Okay, so the people in condos, so they're underrepresented. For some reason I did this one again. Okay, and our last one here. Okay, 2 students were timing each other answering a question. They used the clock in the classroom to time the response. Okay, so this one here is a measurement bias. Okay, you should probably have used maybe a stopwatch instead. Okay, the clock in the classroom is only, it's tough to time it in seconds or milliseconds and so on. So that's definitely a measurement bias because it didn't use the correct equipment. Okay, for some reason on the one I posted is not, I'm missing 2 questions. So this is what should have happened. Okay. One is a survey sent to parents of school-aged children and asked whether bus safety lanes should be installed. Okay, so this was a sample bias because only asking parents of school-aged children. Okay, so you should be asking all parents. Okay, last one, a phone company surveys its customers via text. Okay, on the service they like best. So this would be a non-response because people will probably not respond. They'll probably just delete the message. All right, so going through page 235. 235, example 2 and 3. Okay, so just want to go through example 2 and example 3. Okay, so we're explaining why these are misleading or questionable stats. Okay, so the Daily Mirror and the Times retweeted this tweet about a British high-speed rail project that is expected to take 20 years to complete. Interesting stat, 93% of today's UK population will be dead by the time this is finished. Okay, so why is it misleading? Well, in 20 years, 93% of people will be dead. That seems very unlikely. Okay, because there's 20 years from now, you guys will be in your 30s. People in their 20s will be in their 40s. So I don't expect 90% of people will be dead at that time. So this 93% is definitely very inaccurate. Okay, B. In 2005, the British Cheese Board conducted a study to show that eating cheese does not give you nightmares. I don't know if any of you guys have heard this before, but just kind of a myth or something. If you eat cheese before going to bed, you'll have bad nightmares. So this is kind of a weird statement. And the issue with this is how you actually going to measure this. I'm going to give people cheese and see if they have nightmares. And then what other things contribute to this. Oh my god, dogs are going nuts upstairs. Okay, class. Okay, I'm just gonna tell you this one. Pie charts aren't good for displaying information, so it's tough to gauge percentages in a pie graph. Okay, next one. A newscaster reports about a survey that asked, did scientists falsely research to... You guys can read it. Okay, sorry, I gotta go fix my dogs. I'll be back.